guys, so we are going to talk about parallelograms, which are a type of quadrilateral. So in the quadrilateral family tree here, we have parallelograms, and then among parallelograms we have special types, which are rhombuses, rectangles, and squares. Each of them have their own defining attributes that we can use to help us solve for missing angle measures. Okay, so let's take a look at their attributes. So in a parallelogram, opposite sides are parallel to each other. So the left and right, up and down sides are parallel. Opposite sides are also congruent. Okay, opposite angles are congruent. So the ones directly opposed to each other, like the red and blue, and angles that are next to each other, adjacent or consecutive, are supplementary to each other, meaning they add up to 180, which makes sense because if you think about it, because we have parallel sides, they form transversals, right? So that makes sense. All right. So let's take a look at how we can use some of these properties to solve for missing measures. So here we're looking for UT, which is pretty simple. They have been given SR, so UT has to be congruent to that. And ST is going to have to be congruent to RU. Opposite sides are going to be congruent. Easy enough. Now it's asking us about a diagonal, or portion of the diagonal, VS. Now we know that this diagonal is bisected. It's cut in half, okay, by its intersection in the middle. So each side of this is going to be congruent. Since we know UV is 7, VS also has to be 7, okay? We're also looking for VT, which is half of the other diagonal. Since we're given that RT, the entire length of the longer diagonal, is 30, and we know that they're bisected, we know that each individual half has to be equal to 15. Okay? So, angle measures are going to be working in a very similar fashion. So remember how we said that the opposite sides are parallel. We can use that and the diagonals to form a transversal. So when we're given a portion of one of the angles, what that allows us to do is to use alternate interior angles to say that the other portion is congruent. So if this angle is 21 degrees, then this angle is 21 degrees. If this angle is 71 degrees, then this angle is 71 degrees. And again, that's by alternate interior angles. They've also told us that FED is 134 degrees. So the entire angle from side to side is 134. Since we know that a portion of that is 71 degrees, we can find the other portion of that, the pinkish purple portion, by subtracting away the blue 71. We subtract 71 degrees away, whatever's left has to be the measure of the other portion of that angle. Oh, excuse me. So the other portion would have to be 63 degrees. So DEC is going to give us 63 degrees. Now it's asking us to find CDE. Now that's going to be a little bit more of a challenge. CDE is this larger great angle. And we might have to use some other facts first, find some other information first. So because we know that this one's 63, we know that this is also 63, alternate interior angles. So now we can find some other information. We need CDE, the entire angle on that side. There's a couple of ways that we can do that. Probably the easiest way would be to use these three angles to find the interior angle here. So if I think about a giant triangle in the middle, so there's a triangle formed here, and I know that 21 degrees is a portion of that triangle, and I know that 63 degrees is the other measure. So whatever is left has to be our top angle here, and it has to add up to 180 degrees. Excuse me. So if we add 21 plus 63, we get 84, and when we subtract that from 180, we get 96 degrees. So we know that this interior angle is 96 degrees, which means that this is 96 degrees. It also means that we can use linear pairs to figure out what the angle is directly next to it. Okay? If this angle is 96, then 96 plus this angle has to equal 180. So we take 180, subtract the 96 that we already have, and we're left with 84 degrees. So we know that the other interior angle is 84. Now that we know that this is 84, we can use the top triangles to figure out the remaining angle on the bottom. Let's see. So if I want to find this angle, I take 71 and I add it to 84, which gives me 155. And then when I subtract that from 180, I get the remaining angle of 25 degrees. Since this is 25 degrees, then this has to be 25 degrees. So now we've identified all of the angles that are possible in here. CDE, therefore, is going to be 25 plus 21 degrees, which means the entirety of that angle would be 26 degrees. ECD, we had already determined was 71 degrees. And DFE is 25 degrees. All right. So let's look at how we can use that to solve for some missing measures. Let's see how much more of this we have here. Couple more, so I'm going to stop the video here and continue it in a second part. That way if you want to break this up and take a break, you can.